Hello everyone. Welcome back to my 7-part series that deep dives into Elixir processes called The Process. If you're new to this series and coming in from elsewhere, I'm going to put a link to the entire playlist so that you can make sure you understand all of the prerequisites necessary to get to this point. This is episode 3B, entitled Mox and Ecto. In the previous episode, which was the first episode in part 3 called The Conundrum with Concurrency, I went over the main problem with concurrency, which is managing global state. The problem being when you have some sort of shared global state and a concurrent system that's accessing it, you might need to be able to shard that global state so that each concurrent access sees its own view of the state. And I did that in the context of testing, where each test, in order to be reproducible, needs to be isolated from the global effects of all of the other tests that are going on at the same time. And we constructed a mock system kind of in an ad hoc fashion. And what I'd like to first show you in this part 3B is Mox. That's M-O-X. And Mox is Elixir's preferred system for creating test mocks. And what I'd like to show you is that it works in more or less the same way that I went over in the previous episode. There are some details about how it works under the hood that are designed to make it more efficient, but overall the point being that what you can expect to see is the same. All right, so let's start with the main module that we're going to be testing called Playground. Now, here's how Playground works. It's got a single function called get, which we're going to use to get some sort of value. And in the case where we're in the test environment, it's going to call the module Playground mock and return the value of that module's get function. And in the case of all the other environments, it's going to call Playground real. So, and the contract for both Playground real and Playground mock is this module called Playground API, which defines a single callback get, which returns a string. So when we jump into playground.get, we expect to either run Playground mock or Playground real's get function, which then, in the case of Playground real, returns real. So let's see how that looks. So I'm going to spin up a new shell and run playground.get. And you're going to see, of course, it returns real. Now, what happens if I set the environment to test? Well, of course, we're going to get this undefined error because I haven't defined this Playground mock module anywhere. Incidentally, that's why this thing gets yellow underlined, because Playground mock is not available in the test environment. All right, so let's take a look at where that gets defined. And so that gets defined in testhelper.exs, which is the script that runs is the runner for all of the tests. The important thing to see here is that I have this mox.defmock playground mock for Playground API. And what this macro does is it creates a module called Playground mock that has in it implemented functions for all of the hooks in the Playground API contract. In this case, that's the single get function. So let's take a look at how we're going to test this. The way we're going to test this is pretty simple. We're just going to set up an expectation that the Playground mock module will be called with the function get, and we place in that expectation this zero arity lambda, which takes no arguments and returns the value foo. And then when we call playground.get, remember Playground module will call Playground mock, this get function, and then it'll return foo. So let's go ahead and run that. And it works. Fantastic. Now, the next thing that I want to show you is what happens when we try to run this in a separate thread. So spawn. Let's go ahead and run this. And what it's going to happen is it's going to complain. It says, hey, I don't know what I need in process 438. Now, just for consistency's sake, let's go ahead and inspect what that process was. And you'll see that they match up. So it says, I don't know, I'm in process 438, and I don't know what happened in process 438. Great. So somehow we need to be able to tell Mox that when process 438 calls your playground Mox get function, then it's going to be okay. Just use the one that was defined by the test. Now, if you remember in the previous video, the way we tackled this was by, instead of using a raw spawn, we used task.start. So in theory, this should work. Uh-oh. But now we've got a problem. It still says no expectation defined by process 439, and the task itself was in process 439. So let's stop and think about what actually happened here. Well, remember, this is asynchronous code. So the reason why I really want to show you this is because this is something that is very likely that you'll run into if you're not careful. So remember, task is asynchronous code, right? So what could potentially happen is that this test could launch the task and then quit, thereby freeing the expectation. And then when this task comes around to actually call playground mock.get via the playground.get function, it's gone. The expectation has already been freed. So what we need to do is we need to create coordination between the test process and the task process. So here's how I'm going to do it. I'm just going to do it really easily. So we're going to set test PID equals self. And then I'm going to send test PID unblock message. And then we're just going to assert receive unblock. Okay, so now the lifetime of this expectation matches up with the lifetime of the task. And throughout the whole task, we're able to see the expected playground mock.get function and the test passes. Now, just for completeness, what I'm going to go ahead and I'm going to go back and change this to spawn and show you that that doesn't work. And we get this Mox unexpected call error, and then as a bonus, we got this weird process. This process died because it couldn't find its expectation, and we never got the unblock message. So that's why the process mailbox is empty message came back. Okay, the other way we could have done this is we could have done it this way. So we could have assigned this to a future. Then we don't need this coordination here. And then we can do task.await future. And that should also work. And that works great. So how is it that that the expectation of the playground mock is known to be the expectation from the test? Well, if you remember from the last episode, the way we did this is by taking a gander at the process library. So let's do process.get and then inspect that on our way in. And so here we have callers and ancestors. So what would happen if I did process.delete? Let's delete callers, and let's also delete ancestors. So there's no way for this get mock to be able to tell where it came from. We've deleted all evidence that this emerged from the test PID. All right, so let's run this. And sure enough, we get the same error as before. No expectation defined from playground mock.get in process PID 440.0. And so that's kind of a priori proof that this system of callers and ancestors is how Mox is able to ascertain where the expectation came from. And now it's also important to note that, of course, I've written this task.async or task.start internally within the test. But if you were to have called that from some module elsewhere, then you would have the same effect. Okay, but wherein comes this benefit? So what I want to show you next is that we can reconstruct this ability in a way that will enable us to run two tests in parallel. So let me go ahead and copy paste some code. And so this is the same as what we did before, except here's the first test is going to run these both of these test modules are going to run asynchronously because they have async true going on. And the first one is going to get set the expectation of get to be foo. We're going to put a 1 just as a place marker to show us when that happened. Then we're going to sleep for 100 milliseconds. And then we're going to attempt to access it. The second module is going to do something simpler, except it's going to implant the value bar. And then we're going to put the number 2 in there, or print the number 2 to show us where we were. Then we're going to sleep for only 50 seconds. And then we're going to run the get function, right? So what should happen is these two tests should start more or less at the same time. Might be indeterminate which one goes first. But this one will drop its value in first. This one will then drop its value. And then this one will fetch its value. And the other one will fetch its value next. So let's go. So we should see 1, 2, or maybe 2, 1. And then we're going to see foo, or bar, then foo. And we'll see that both of these two, which are setting what is a global setting system, aka the playground Mox system, be sharded between the two different tests. So let's go ahead and run this test. And we see 1, 2. So that's this one. Then this one. Then we slept for 50 milliseconds, got bar from this mock, and then a little bit later we got foo from this mock right here. So these two mocks were able to set their values, or these two tests were able to set the values of the mocks separately, and they didn't collide with each other. And so this is why you want to use tasks in a lot of your systems internally within Elixir, because they will respect the system. And if you set your async to be true, you can still do mocks in a concurrent fashion. And I think that this is like one of the huge superpowers of Elixir. I don't know of any other systems where you can have mocks that respect the concurrent nature of your test runner. Okay, so the next thing we're going to look at is databases. And so in order to do this, what I've done is I've set up a little bit of a database using Ecto, which is Elixir's preferred database management system. And just to kind of orient you to how it works, it's pretty simple. I have a single schema which maps to a single table. That table is called data, and there's a single column in that table called value, and value stores a string. And that's all this says. This is this view onto that schema. Let's look at Playground DB module. And Playground DB module implements two functions. One is called put, which will allow us to put some data into the database using the schema module and a pretty trivial change set. And then it'll run an insert function against the database repo. And get all will just, call the database against that chain or schema, and it will just dump everything in the database as a list. So let's look at our database test. And so this is pretty simple. What we're going to do is, I'm actually going to comment this out for now. We're going to run a get all against the database, and the database should start out empty, and so we should get an empty list. Then we're going to put a single value foo into the database, so a single row with the value foo, or the foo value inside the value column. And then we're going to see that we get the expected value out. So when we call get all, we're going to get the value. And so if you're like really prudent and experienced with databases, you might see the problem with this test. But we're just going to go ahead and run it anyways. So let's do playground db test. And so great, this test worked. Look at this. So we did a query that selected all from the table data, right? And returned nothing, right? And then we did a second query where we inserted into the database table data the value that we expected. And then we did the third one, which was to query data, right? And then select everything, and we got back exactly what we expected: a single list with a struct with the field value filled with the value foo. So where's the problem? This test passed. Well, what happens if I run the test again? So now we got a problem. We got a failure. And what was the failure that we got? On the first line here, line 9, when we tried to get all things in the database, we got this data that happened to be persisted from the last time that we ran the database, right? And then it gets even worse. If I run it again, then now we've got so we still have that data from before. So that's not good. It's not really particularly helpful if we can only run database queries once. So ideally what we would like to do is to have the database perform a bunch of tasks, the database engine perform a bunch of tasks against the database in our test. And then when it's done, roll back everything as if nothing had happened and restored the database to a clean state. Now the good news is that most of the Ecto adapters, well in particular Postgres, which is what you're probably going to be using, has this capability built in to the system. And so let's go ahead and take a look at how we set that up. But before we do that, what I'm going to do is I'm going to clean up our database. So I'm going to do mix ecto.drop, and then we're going to do mix ecto create, and then we're going to run a migration, mix ecto.migrate. I've actually aliased this to a single command called mix ecto.reset. So you may want to be able to do that. Other places will show you how to set up aliases in Mix. It's a super useful alias to have, but I'm not going to cover that. So let's go ahead and kind of adjust this so that everything works hunky-dory. So the first thing we're going to do is we're going to set up something called sandboxes. And in order to do this, I need to add this line in the config, which sets it up so that the playground repo takes a sandbox pool. I'll be honest, I don't fully understand what magic is going on here, but this is a necessary step to activate sandboxes. In a normal Elixir project, you probably want to put this in your test.exs only and not in your main config.exs. But for simplicity's sake, I didn't split them up in this example. The next thing that you're going to want to do is you're going to want to set the sandbox mode to manual. So this I have in the test helpers EXS file. And what this will do is manual sandbox mode means that you have to manually check out a transaction, and all of your changes to the database are going to happen in your transaction. And when that process dies, your transaction will be cleaned up by just using Erlang's system for listening to listening to processes, and it will automatically basically garbage collect your database connection, and as a natural process of an incomplete and uncommitted uncommitted transaction, everything that happens to the database will get rolled back. So what's cool is this is a merging of the nature of how Erlang processes give you a natural way of cleaning up all of your resources with the system of databases where your database connection can take out a transaction, and unless the contents are committed at the end of the transaction, everything gets rolled back. It's really quite beautiful. Okay, and the last thing we're going to do is we have to actually set up we actually have to check out our transaction, and the way we do that is by activating this checkout function inside of our test. So every test in this module will create a new transaction checkout from the sandbox. Now, for larger scale projects, you probably don't want to have to write this on the top of everything, so you might write a macro for it. But do note that, you want to, in my opinion, you want to make it crystal clear that every time you are running a test, and this is just to promote good design, every time you're running a test that this is happening. Great. So now let's run this basic test that I wrote, right? And we're going to run the test. And now you can see it passes. Well, it passed correctly the first time as well. So let's run it again. And you can see that I can run it as many times as I want, and each time it will roll back the changes. Great. So let's also go ahead and see that this entire thing works as we expect, or will fail to work if we put this inside of a spawned process. Okay, what happened? Why did this test pass? We have one test, 0 failures. Well, if you look at very carefully at what happened, we have this finished in 0.1 seconds happening here, and then the last thing that we do is we have this debug query error. So what we did was we ran the first get all, then we ran the put command, and then we finished the test, and then we never performed the get all because this was in a concurrent process. So this is super challenging, right? You have to worry about race conditions. Basically what happened was this test finished itself and cleared the checkout before it could do this assert. So this assert never happened in the test process. It happened elsewhere. So we have to kind of fix that. So how are we going to fix that? We're going to fix that by doing exactly the same trick that we did before. So what we're going to do is we're going to assign test PID to self, right? And then we're going to send self or send test PID an unblock message. And then what we're going to do is we're going to assert receive unblock. Okay, so now let's run this. And what you'll see is, aha, now we get an error. And first the thing is that it says, we can't find the ownership process for the database connection. So let's also go ahead and spy on what the identity of this spawn process is. And so our spawn process is 442, and it says process 442 raised an exception. Can't find the ownership process. I don't know which database transaction to match up with this. It caused an exception to happen here. This process crashed. It never sent the unblock, and to make matters worse, we never received this unblock statement at the end. Okay. So how do we resolve this? Well, the easy way to do it is to do task.start. And boom, now everything works because somehow the task system will allow the database driver to see what's going on and be able to match up this concurrent process with the parent process, which is the test. That test is itself associated with this sandbox checkout. Okay, so I'm not going to show you task.async because you should just trust me that works in exactly the same way. But what we will do is we will take a quick look at the process dictionary, and then we'll go ahead and erase the ancestors and callers. Right? And then now when we try to run it, you're going to see that it doesn't know, cannot find the ownership process. So I think that the important thing to remember is that when you see these weird cannot find ownership process errors, or cannot find the mock error, what the problem is that it can't see, it's been spawned by some other process besides task.start. Okay, so great. So now let's go ahead and also take a quick look at two of these things running simultaneously. Okay, so in order to do that, what I'm going to do is I'm going to go ahead and revert this back to what it used to be. Make sure that works. And then we're just going to go ahead and copy and paste. We're going to, for the second one, we're going to put in the value bar. And then what we're going to do is we've got to make this the second test. And what I'm going to do is I'm going to print out the fact that 2 and put 1. And then we're going to inspect these. Okay, so let's go ahead and run these. And we see that 2 pieces of data have been inserted. So we have an insert here, or a query here, and then we put 2, and then we put 1, right? And then we see these data be inserted. So in this case, bar happened to hit before foo. And then we see both queries happen, and we see that 27 gave a value of bar, and line 12 gave a value of foo, which is exactly what we'd expect. And I can run this again, and it's possible that they'll hit in a different order. It looks like 2 happened before 1, but either way, the point is that this is a perfectly concurrency safe way of dealing with these things, because each of these tests lives in its own checkout. And even though these are running simultaneously and at the same time, each checkout is its own little universe of what the database should see. And so they can hit the database and make changes, independently of each other. And you can go ahead and test your database logic in an integration style without having to worry about setting up rollbacks, because all of those will be automatically handled for you by the system. Okay, so the last thing that I want to show you goes back to part 3, or part 3C. And so the topic for part 3C is going to be exiting the VM. I'm not going to show you the details of how we can get this to work, but I'm going to give you a little bit of a teaser of what to expect as sort of the magical thing that's going to happen in the next episode. All right, so here's what I've done. Inside the same repo, I've created a plug, and so this will get. This is basically just a system of web routes, and I can access these routes by just going to HTTP localhost 4001/mock or 4001/database. And of course, this is going to hit the playground.get function. And remember, the playground.get function is backed by a mock, and the playground.db get all is going to be backed by the database. So what I would love to do is to be able to do a full integration test where, I go ahead and issue an HTTP request out to the existing server. So this is what I mean by exiting the VM. So I'm going to start with an HTTP request that it lives inside of the VM. It's going to go over the TCP socket and leave the VM via TCP/IP and then come back into the VM. And somehow it's got to be able to connect up to these mocks. Let's take a quick look at the exit test. I haven't completely written all of the tests for the database yet, but we'll take a look at the VM test. And basically, here's how it works. So I'm going to use this library called Finch, which is an excellent HTTP library. It's going to build a GET request against the localhost mock path, which is just going to be HTTP localhost 4001/route. It's going to issue the request, and then we're going to try to pull the body off of that request, and it should have the word foo in it because I have created the expectation that playground mock.get or the get function will be foo, right? And so I'm going against the mock route. Let's go ahead and see what happens when we try to run this test. Okay, so obviously we get a failure because we're going to have to do a little bit more work to get this to work. But let's actually look at the specific nature of this. So in the first place, this is actually unrelated to the test itself. We're getting the no expectation defined for playground.mock_get0, right? So basically, when we re-entered the VM, we were unable to find this expectation of foo for playground mock.get. Then in the response, we got a 500, right? Status 500. And so typically for plug, which is the Erlang HTTP server, one of the HTTP server system, when we get a 500, that means that one of the processes that typically means that one of the Erlang processes that you've been running has crashed. And so this is what we would expect since the request handler crashed. And so the challenge that we need to figure out is how to get this to correctly connect back up to this expectation. And so that's what you're going to see in the next episode. Take care.